Now I'd like to actually apply it to a relevant statistical example, right? Because it's relevant that's interesting. And this is a theory that I have. How many people are workaholic losers like me who often eat their dinner out of a vending machine? Right? How many people have ever had, okay, we actually have normal people here. One guy's like, I don't want to admit it, but have you tried the Oreo cookies out of the vending machine? I think they're drier than the ones in the store. Yeah, okay, so right. So obviously you share my conspiracy theory on this, right? I was convinced that the Oreos in the vending machines had less cream filling, and that this was some sort of conspiracy by the RGR Nabisco Corporation. I didn't have time to test it myself, so I found the only willing scientist at the time who was willing to test this hypothesis. This is my daughter Miranda, and this was her 4th grade science project. Isn't she cute there? Yeah. She's 17 now, and now she reminds me every time I say something she doesn't like that, Dad, you know the person who's going to pick the home you go into is me. Now, I didn't help her a little bit. I helped her a little bit with the statistics, and I had a very important job consuming the leftover cookies. So she would scrape the cream filling off and then weigh the cookie parts and get the cream filling amount by difference. And here is her data. And if you look at that far right column, right, that's the filling. Those two are spot on. And in fact, they are statistically significant to greater than 99% confidence. Those error bars are the 99% confidence interval. So I was very impressed that they got this filling spot on. But notice, whether you take the max, the min, or the average of the cookie wafers, they're off by almost 15%. And it is statistically significant, right? Those error bars don't overlap at all. So I wondered, what is going on here? So the first thing we did was write the RGR Nabisco Corporation. And they assured me that they make the cookies the same for the vending machines or for the store. But I was undaunted, and I sent the data in. I said, look, are you sure? Because I'm still convinced there's some kind of cream-filling conspiracy, or maybe now you're messing with the cookies. I don't know. And you know, they sent me this polite reply, but again, you know, you have to be stubborn if you're a scientist. So I sent them one more letter. They were not amused at all. And apparently I'm on some sort of list now. Any emails I send them now do go to the security division. So we never solved that problem. But here's the quiz portion of tonight's program. What do you think the difference was? Water. Yeah, exactly. So what does the front of your shirt say? Yeah, science. It works, bitches. Yeah. A friend of mine wore that in the Cobb County Parade with the Americans United for Separation of Church and State. They did not like that shirt on there. Right. That one's got the decay curve on the back. Yeah, it's a great shirt until a bunch of conservative people in Cobb County beat the crap out of you. So you're right? That's it, right? They assured me they were the same, so the only possibility is you're actually getting water going in, right? So it's probably water that's going through the cellophane because the packages in the vending machines are a metal plastic laminate. They're actually aluminum. So believe it or not, none of those plastic wraps work all that well. I work in that field. Trust me, they're not that good. Aluminum foil is much better at keeping water out or in and air out or in. So those two little old ladies that tell you to fold the Reynolds wrap, they're actually correct. I just can't fold the Reynolds wrap, so I use the plastic stuff. But that's basically the reason behind it. And I want to give one more example about political polling, and that's because I took this from November when I was doing a show in New Orleans. And in New Orleans, no one could actually believe that Newt Gingrich from right here in Georgia was on top of the polls back then, right? And you'll notice the one place where they always give you an error bar is with the polls. And it's calculated exactly that same way. So if you take the probability of people liking Newt Gingrich multiplied by the total number of people, it's just that t-value times this is the standard deviation. It comes from the theoretical value from the binomial distribution. You divide through by n, and you get that probability plus or minus this formula. You plug it in, 0.28 plus or minus 3.9%. That's where the 4% comes from, right? And no one could believe in New Orleans that he was actually ahead, because they remember that story. We did that nice little class up at Kennesaw State University, and he got in trouble because he televised it with campaign contributions, right? And then they don't understand Kennesaw's, where they actually are required to have a gun in their house, so it's a little strange. But what's interesting is the margin of error actually does become quite significant. It's about 3% for 1,000, depending on what the probability is. And that's typically what they poll for people. It's around 1,000. And then when it gets to 100, it gets much bigger. By the time it's 10, it's basically worthless. If you just ask two yokels off the street, it's 450%. So it's utterly worthless when you ask two people, right? You can tell nothing about the polling when you ask two people, unless you ask those two people in Kennesaw. Then you're sure there's a 26% chance of getting a cat popped in your ass. Of course, it's even better if you ask Newt Gingrich in Kennesaw. There's an 85% chance he's going to sell you one of his books and probably pop a cap in your ass. And then I can't quit without talking a little bit about Six Sigma. How many people do Six Sigma where they work? Okay, who made the hissy sound? Not a fan of Six Sigma? Whoever made the hissy sound? Me neither. Not a big fan of Six Sigma, right? So basically, Six Sigma combines two things. It combines the DMAIC process, define, measure, analyze, improve, think that one up, and the fact that what you want to do is make sure all your products are of reasonable quality between plus or minus 6 sigma, right? And that means you have to make sigma so small that between plus or minus 6 sigma, those are still high quality products that aren't going to fail and be returned, right? Basically what that means is 1 in 506 million will be faulty, right? And anyone who runs a business knows that most businesses don't need that level of precision. And in fact, if you read the literature on this, they actually changed their mind. They actually made it 4.5 sigma. They don't tell you that. So now it's still 147,000, 1 out of 147,000. But still, that's 99.9993% of the products meet your specifications, right? And that doesn't make sense for a lot of industries. For example, the Rubbermaid Corporation, which uses Six Sigma, right? It makes no sense to invest the time and resources to get that level of precision in making your products. Because you make little polypropylene tubs, right? If 1 in a few thousand is bad, you take it, you throw it in the hopper at the beginning, you remelt it, you re-injection mold it, and you're done, right? In fact, it's much better if a company like Rubbermaid would not invest in trying to get this standard of precision, but in fact would find a way to get the United States government to buy millions and millions of polypropylene tubs. That's a much better business decision. That's all I'm saying, right? And probably the only place where this belongs is the place where it started, the microelectronics industry, right? So I actually do work for Intel Corporation, and I work in this field, and the reason it's important for them is because you have 100 steps. So it's good to have that 99.9993% precision in making these things the right way if you have 100 steps, because you take that to 100, and then suddenly, almost 1 in 1,000 is bad, right? 1 in 1,000 may not seem like that much until you get the chip that's the 1 in 1,000 and got to return your laptop, right? But even then, it's hard to get the Intel guys to embrace Six Sigma. Right? What do they have to do? They have to give you a certification with a cool martial arts name, the black belt certification in Six Sigma. Do we get any black belts in Six Sigma? Okay, because most black belts in Six Sigma actually do it for the pay raise that usually companies get. And I think there's a bit of a conspiracy here about that. It's not the first time someone has given a cool martial arts name to make something that was really sound really cool, right? It was first applied by the Hasbro Corporation in the 70s to everyone's favorite G.I. Joe, G.I. Joe with the Kung Fu Grip. Right? You got to be old to remember that one. But think about it. When Hasbro first came out with it, what did they have? They had springy-handed G.I. Joe. Yeah, that wasn't too good, right? So they tried a few different things. They tried ass-scratch G.I. Joe. That didn't do too well. For a while, they tried puberty G.I. Joe. Again, that was not very popular. And then they put 2 to a package, called it Grab-Ass G.I. Joe. And that became very popular during the Clinton administration when it was finally marketed as the Don't Ask, Don't Tell G.I. Joe. It continues to this day. Actually, the newer G.I. Joes, they discontinued this about a year ago, but about 3 years ago, they came out with their new cartoon and their new marketing campaign. I kid you not, G.I. Joe Sigma 6. Coincidence? I think not. All right, so let me shift gears and talk a little bit about chemical stuff. And I like chemical stuff so much that actually when I'm out doing stand-up comedy, I was doing stand-up comedy in Kennesaw once, and I like to do an educational segment that I like to call There Are No Bad Chemicals, Just Bad Chemical Names. Right? How many people are like me? They read the ingredients on consumer products just for fun? Oh man, again, you guys do not have a particularly good social life then.